morning, everybody. So right now I am going to continue that is the diffusion of respiratory gases. Last time I discussed that is the breathing mechanism as well as some muscles responsible during inspiration and expiration. Today I am going to discuss some processes of diffusion of respiratory gases. So, diffusion of respiratory gases. Diffusion of respiratory gases. The diffusion, site of diffusion, site of diffusion of respiratory gases, are two in number. Two. That is, first, that is the respiratory gases diffuses between alveoli and blood. The respiratory gas diffuses between alveoli and blood. Here, two or three important points which affect the rate of diffusion. So, first of all, that is the factors affect the rate of diffusion. Factors affect the rate of diffusion. First is solubility. Solubility, that is you can say that solubility directly proportional to the rate of diffusion. Solubility directly proportional to the rate of diffusion means that if the solubility of a gas is maximum, so that the rate of diffusion also would be maximum. Now, the most important point here is that the solubility of CO2 is approximately 20 to 25% higher compared to oxygen. So, here the solubility of approximately 20 to 25% higher. 20 to 25% higher compared to oxygen. So that CO2 is much soluble or more soluble compared to O2. That is why even though in low partial pressure, the difference between partial pressure of venous and alveolar air is still very less, but the rate of diffusion is more as compared to the partial pressure of oxygen in alveoli as well as the partial pressure of oxygen in blood, due to solubility. And it is a very good question. If the question designed from this particular point, then definitely it will create a very high degree of difficult question. Now, next thing, that is membrane thickness. Membrane thickness, again, the thickness of a membrane or the surface where the exchange of respiratory gases going to occur or takes place is also play a significant role which determine the rate of diffusion. Simply, you have to know as a mathematical derivation, that is the thickness of membrane. Thickness of membrane is inversely proportional to the rate of diffusion. It means that if the thickness of membrane is increasing, the rate of diffusion will decrease, or in reverse direction, the rate of diffusion is slower or less. It means that the thickness of membrane is high. Clear? Now, third thing, that is the partial pressure. Difference in partial pressure. Creates diffusion potential. And as you know, the basic law of diffusion or the thumb rule is that is the diffusion of respiratory gases or any gases takes place from higher potential or the higher partial pressure to the lower partial pressure. Now I am going to this point, that is the first side of respiratory gases diffuses between alveoli and blood. So these are the some three factors. I am going to repeat it. First is solubility, second is thickness of membrane, and third is the partial pressure potential or difference in pressure potential. So these are three important. There are other factors also, but these are the three main important factors up to your level for as per NCERT, you have to focus up to this. Now, the most important discussion is that the respiratory gases diffuses between alveoli and blood. So, what are those two important resistance that you think that is that these resistance will stop or decreases the rate of diffusion or facilitate the rate of diffusion? Like, as per you know that in alveoli and blood vessels. Alveoli and blood vessels. So, in alveoli and blood vessels, there are three membranes. Three barrier, that is the membrane. First is alveoli, squamous epithelium. Second one is basement membrane. And third one is endothelium, squamous epithelium. So these three barriers actually creates a resistance between alveolus air and blood air. So the total thickness of these three membranes, of these three barriers, is approximately 0.2 millimeter. So it is a thin membrane. Therefore, it facilitates or support the rate of diffusion. So that is why the alveoli and endothelium facilitates the rate of diffusion. Why it is so? Due to the very thin membrane. Okay. Now, second. So this is the first barrier. First barrier, or you can say that factors which are responsible for the determining the rate of diffusion. Now, second one is the partial pressure. Partial pressure of respiratory gases. partial pressure of respiratory gases. So, in alveolus, in atmosphere, in alveolus and in blood vessels. So, in atmosphere approximately 149, in alveolus approximately 104 mm of Hg, and in blood vessels it is approximately 95 mm of Hg. And in tissue it is approximately 40 mm of Hg. So this is the partial pressure of O2. Partial pressure of O2. Similarly, in partial pressure of CO2, it is approximately 0.3, and in alveolus it is 40 mm of Hg, and in blood approximately 45 mm of Hg, and at tissue that is the 45 mm of Hg. So, blood vessels here is artery and vein. So, you simply notice that the difference in partial pressure of oxygen and carbon dioxide creates the diffusion potential, and the thumb rule is that the gases will move from high potential to low potential. So that is here you easily noticed, and it is written in NCERT also, the difference in partial potential or difference in partial pressure potential, so that gas move according to that direction. Means that in alveolus the oxygen are at high potential, while in blood vessels oxygen are at low potential, like this. Similarly, if we take about the alveolus and this blood vessels, so blood vessels in artery and vein, ठीक है? Now, basically, you know that in last classes, that is the systemic circulation of blood, that is the systemic artery and systemic vein, where the partial pressure in systemic artery, the partial pressure of oxygen in systemic artery is approximately 95, and the partial pressure of carbon dioxide in systemic artery is approximately 40. While in the partial pressure of oxygen in systemic vein is approximately 40 mmHg, and the partial pressure of carbon dioxide in systemic vein is approximately 45 mmHg. So now this creates the diffusion potential. So this facilitates the diffusion. Now in second level, that is the first and this is the second side. Respiratory gases diffuses between tissue blood and tissue, blood and tissue, blood and tissue. Again, that is the difference in partial pressure, difference in partial pressure, partial pressure responsible for exchange of respiratory gases, responsible for exchange of respiratory gases, like in tissue, there is partial pressure, tissue basically a fluid, the partial pressure of O2 in tissue fluid, the partial pressure of oxygen in tissue fluid is approximately 40 mm of H, while partial pressure of CO2 in tissue fluid is approximately 45 mm of Hg. This increase in partial pressure of tissue fluid is the result of metabolic process in tissue or cell. Now, in blood capillaries, the partial pressure of O2 is 95 mm of Hg and partial pressure of CO2 is 40 mm of Hg. So that easily you can determine the difference in partial pressure which creates the potential. So, due to the increase in potential pressure, oxygen moves, O2 moves from blood to tissue, that is the O2 moves from blood to tissue, and CO2 moves, that is the CO2 diffuse from tissue fluid to blood capillaries, tissue fluid to blood capillaries. So, this is the actual role of partial pressure potential for the diffusion of respiratory gases. As I already discussed, the factors which affects the rate of diffusion is solubility, thickness of the membrane as well as partial pressure. Okay. Now, next. I'm going to discuss again different respiratory volume and capacities. Different respiratory volume and capacities. So, first, that is the tidal volume. That is the TV, and its value is approximately 500 ml. 500 ml. Now, how you define this tidal volume in simple word? That is the amount of air that we can inspire or expire. The amount of air that we can inspire or expire with each quiet breath. एक नॉर्मल शांत सांस का लेना और सांसों की एक्सहेलेशन और इनहेलेशन in a normal state, steady state, is said to be is called tidal volume, and its value is 500 ml. Second, IRV, that is the inspiratory reserve volume. Inspiratory reserve volume. Its value is approximately 3000 ml. 3000 ml. Now, how you define inspiratory reserve volume? That is the amount of air that can be maximally breathed in, amount of air that can be maximally breathed in at the end of forceful inspiration. At the end of forceful inspiration. Means forcefully amount of air that can be maximally breathed in at the end of, that is the forceful inspiration. जब आप बहुत अंदर you have to maximally inhale an air, that is the inspiratory reserve volume. Now, after that, ERV, that is expiratory reserve volume. Expiratory reserve volume, and its value approximately 1100 ml. Expiratory reserve volume, its value approximately 1100 ml. Again, the amount of air which remains, amount of air which can be exhaled, forcefully at the end of expiration. At the end of expiration. Now, next one is RV, that is the residual volume. is approximately 1200 ml. 1200 ml. That is the amount of air remain in the lungs after quiet exhalation or expiration. After quiet expiration, you can say that is the forceful expiration. Forceful expiration. Now, next, that is the capacity. Capacity. First is vital capacity. That is TB plus IRB plus ERB. That is the total amount of air maximally breathe out after first maximum inspiration. First maximum inspiration. Second, that is the inspiratory capacity, that is the IC, and it's equal to TB plus IRB, that is total volume of air which are breathe in during inspiration. Second, third is expiratory capacity, that is TB plus ERB. Fourth one, total lungs capacity. Total lungs capacity equal to TB plus IRB plus ERB plus RB. So that is the total amount of air during forceful expiration and forceful inspiration. Now, next, FRC, that is the functional residual volume. Functional residual volume, that is the amount of air present inside the lungs at the end of quiet expiration. So that one is important. At the end of quiet expiration, and its volume is, that is the TB plus ERB. Now, two important factors regarding this capacity, that is during During maximal inspiration, lungs are at TLC. During maximal expiration, that is the forceful, lungs are at RV. During maximal expiration, that is the quiet, breathe out. Lungs are at